Lassen Peak earthquake swarm on June 24, just 50 minutes after midnight, a swarm of earthquakes began striking adjacent to California's active Lassen Peak volcano, which last erupted in 1917. While these earthquakes were quite small, they kept occurring one after the other, unlike what would be expected in a typical foreshock or aftershock sequence. Across the next 8 hours, the rate of earthquakes continued to increase, until it reached a peak at 8:50 a.m. local time, generating the largest event in the swarm which could even theoretically have been felt, a magnitude 2.5. Activity then declined across the next 11 hours, involving about 3 dozen more earthquakes until this swarm ceased altogether. In all, approximately 100 earthquakes had struck, which could technically be classified as volcanic in origin, marking this California volcano's largest such swarm in a decade. However, this swarm was not at all concerning, as it was not triggered by magma movement but rather from heated geothermal fluids rising from underground. Generally speaking, the more extensive a volcano's geothermal system is, the more earthquake swarms of this variety it will experience. This is why the Yellowstone volcano in Wyoming, which contains the largest and most extensive geothermal system of any volcano on the planet, also experiences highly frequent geothermal earthquake swarms which do not imply any suspicious activity. Since Lassen Peak contains the largest grouping of geothermal features in the Cascade Mountain range, it too produces fairly frequent earthquake swarms, which just like Yellowstone could be considered part of the normal background activity in a non-eruptive state. You can even see this pattern when I overlay a USGS map of every single historical earthquake which has been recorded in and a bit outside of Lassen Volcanic National Park, as clusters of earthquakes occur adjacent to, albeit primarily just uphill, of known hot springs, mud pots, and fumaroles. In the case of the latest earthquake swarm, which produced 17 events larger than magnitude 1.0, they occurred 3,700 to 8,500 feet away from the terminal geyser. Although magma is solidifying about 8.5 kilometers or 5.3 miles beneath Lassen Peak, it is still hot enough to transfer heat into groundwater following rain and snowfall events. This heated water then hydrothermal origin rises, along with some volcanic gases, into weak spots in the crust, lubricating pre-existing fault lines, which makes them more likely to slip. The earthquake swarm we just observed may have been directly linked to a heavy snowfall event which occurred on May 4. A lesser earthquake swarm occurred essentially in the same area on October 31 of 2022, also approximately 7 weeks after a major precipitation event.